All right, welcome everybody. So this is now going to be the second video for Chem 128 Lab 5, decomposition of ammonium chloride. We are now going to be doing 3 trials, so this video is only going to be trial 1, for the reaction between ammonia and hydrochloric acid. So we're trying to find the change in heat when ammonia and hydrochloric acid react. Okay, a couple differences in this video compared to video number 1. First, I realized video number 1, the temperature was kind of small, so I zoomed that in so it's hopefully easier to record on this video and subsequent videos. Okay, we still have our balance over here, currently zeroed out. Our coffee cup calorimeter now has a stir bar in the bottom, so that when we put it on here, I can have it stirring the 2 reactants together. That will enable me to not haphazardly hand swirl our reaction. Okay, and then this time, instead of having hot water and cold water, we are now going to be reacting 2 molar hydrochloric acid and 2 molar ammonium hydroxide. One note, ammonium hydroxide is really just ammonia dissolved in water. So if you think about NH3, it's polar, it's attracted to water, which is also polar. And so NH3, if you add H2O to it, you end up with now 4 H's on the ammonium with an OH on the end. So ammonium hydroxide is simply NH3 plus H2O. Okay, so that's why ammonia in water is the same thing as ammonium hydroxide. Okay, hopefully that makes sense. So these are our 2 reactants. We're going to measure 25 milliliters of each. So that's the first thing that I'm going to do, actually. So we're going to take 25 milliliters of our hydrochloric acid. And I'm going to slightly over pour this and then use our pipette to kind of get down under. And I'm going to have you all record the exact volume. Okay, so use the burette reader. Let me zoom this in maybe. Okay, so record the exact volume that is in this graduated cylinder in your data table, because you need that information. Okay. Now we're going to do the exact same thing with the ammonia over here. And I'm going to over pour slightly and then take some off. Okay, and again, you want to know the exact volume that we have in your data table. So this is the ammonia, so make sure you record the volume exactly for the ammonia. Okay, now we need to put these together in our calorimeter. So it doesn't matter which one goes in first. So I'm just going to pour the hydrochloric acid in first. So we got that there. And we need our initial temperature. So I'm going to take our thermistor. It's now in the hydrochloric acid. And here's our temperature over here. Okay, so record the initial temperature. And if you think about it, this is the initial temperature for both the hydrochloric acid and the ammonium hydroxide, because they both have been sitting out on this desk. Yeah, so they should be at the same temperature. I just realized I need my clamp over here, so I'm going to move this clamp. Okay, so you should have your initial temperature. Oh, it's cooled off a little bit. So that's our initial temperature. So maybe adjust your initial temperature because it was actually it's a little bit cooler now than it was. Okay, so we are now going to get this out of the way. We are going to, what I'm going to do, so I'm going to do this fairly quickly. I'm going to pour the ammonia in, cork it, lower the thermistor, and turn the stir bar on. Okay, and then we'll record our the highest temperature that we see. Okay, so and actually I'm going to go ahead and start the stir bar. So you see our stir bar is now going. So here we go. Ammonia in, cork, lower the thermistor. Okay, so we see our temperature rising up over here. So you're going to watch closely and record the highest temperature that you see. So we have our initial temperature that we recorded for the HCl, and this is going to be record whatever the highest temperature that you see is before it starts to cool back down. It's still going up, but it's slowing way down. Still creeping up just a little bit. Okay, we'll wait for a few extra seconds here. Make sure it's really reached its peak and is headed back down. And so you'll notice this is different from the lab sims, where in lab sims it reached its peak temperature almost immediately and then started cooling down, whereas in real life it kind of takes a little bit of time to get all the reaction to fully react, and then temperature will slowly start to come back down. But it is not an instantaneous thing, because actually apparently a little bit more reaction has started because it's kind of creeping back up again. And I would say we are good now, because the temperature is now definitely headed in the opposite direction. It is very slowly cooling as heat very slowly leaks out of the calorimeter. So keep in mind that beforehand we had there's energy in the bonds of our two reactants, the ammonia and the hydrochloric acid. So there's energy in those bonds, and when there's a reaction, it takes energy to break those bonds, and as they reform new bonds, energy is released. And in this case, we see that our temperature went up overall. So what that means is that there was a net release of energy. The energy absorbed to break bonds was less than the energy released when new bonds were formed. Okay, so inside this calorimeter, we have energy being released overall from new bonds being formed. Okay, and then that energy causes the water to heat up. And then after a chunk of time, this calorimeter holds the heat in fairly well, but over a period of time, that energy will eventually start to leak out of the calorimeter and into the atmosphere around it. Okay, and so that's why the temperature eventually starts to fall back down, and we can see that we've clearly fallen off where the peak was. So that will be the conclusion of this video. Oh, I keep forgetting one final measurement. We need to know what the mass was of the calorimeter. Okay, so let's take our thermistor out here. Okay, turn the stir bar off. Okay, make sure our balance is zeroed. Okay, now this here is the mass of everything together. So this is the hydrochloric acid, the ammonia, the calorimeter, and the stir bar. Okay, so if you've got that mass, okay, I'm now going to pour this out into the waste beaker. I'm going to catch the stir bar here. because I also forgot to find the mass of the calorimeter with the stir bar initially. But the nice thing is you can always go back and do that afterwards. So here we go. This is the mass of our empty calorimeter with the stir bar. So we just took the mass of the whole thing, and then now this is the mass with the just calorimeter and stir bar. All right, now this is the conclusion of our video because we now have the ability to find the mass of reactants that we had working in our calorimeter here. We know the initial and the final temperature, and yeah. And we know the volume, so we can calculate the moles. So we have all the information that we need in order to calculate the delta H of reaction here. All right, on to video number 3 for trial number 2.